Okay, so we are going to demonstrate the NoSQL project right now. This is the brief overview of the architecture. We have one ELB, Elastic Load Balancer. Behind that, we have three different nodes connected to this ELB. And these three nodes are in three different AZs and also having three different subnets. As you can see that the first node is having subnet of 172.30.0.0 and is in zone US West 2A. The second node is having subnet of 172.30.10 and it is in US West 2B AZ. The third node is having the subnet of 172.30.20 and it is in US West 2Z AZ. These three nodes are not publicly accessible. These IPs that you see are private IPs. So in order to contact any of these three nodes, we have to use the public DNS of the ELB. A request will, when we send a request to this public DNS, it comes to the ELB, and due to the security rule that we have configured in the ELB, the requests will be forwarded to any of these nodes randomly. Along with these three nodes, we have also created a jump box, which is nothing but an EC2 instance, which can be accessible from the internet, or rather having a public IP, and also they are able to talk to any of these three nodes in the private network. So using this particular EC2 instance, we should be able to SSH into these three nodes and do administration work. So we'll just quickly have a look into the setup. So this is the load balancer we have. This is the public TNS of the load balancer. These are the three instances which we were just talking about. All of them are out of service at this point. Reason being, we have created a health check rule on TCP 80. That is, if there is some server running on 80 port in these nodes, then the ELB will send a TCP message to this server, and if there is a response that it's getting, then it will consider this node as in service. So the server that we have designed is not running right now. Once it is start running, it will start responding to requests in port 80. So when we start running the servers, we should be able to see that these nodes are going into in-service mode. So this is the listener rule, which says that the ELB will receive the HTTP requests in port 80 and it will forward those HTTP requests into port 80. And we have the security group configured for the ELB, which says it can receive HTTP requests on port 80 and it can send HTTP requests through the port 80. Right? It's pretty simple. We'll have a look into the instances. The name are host 1, host 2 and host 3. They are in three different availability zones and all three availability zones are given three different subnets. They are these ones respectively, and all these three instances are in the same VPC. We can see here host 1, 2, 3, and this is the jump box that we have. If we just click on any of the no instance, we can see that they don't have a public IP or elastic IP. They just have a private IP, so they are not accessible from the internet. And the rules they have are something like this. So it can receive HTTP requests on port 80 from anywhere. It can talk to people who are in 172.30 subnet over 8080. This means the three nodes which are there behind the ELB, they are into this network range, and for replication and administration purposes, they need to talk to each other. And in order to do that, this 8080 port is open. We have also opened port 22 so that we can SSH from the jump box to this host for administration purposes. If we just quickly see what jump box is, it's pretty much the same thing, just that it has got a public IP and elastic IP as well. And its rule are something like this. We have allowed FTP also, so that we can put some files from the internet to the nodes through the jump box. To run all these instances, we have used this AMI, and they are all in the same VPC, this AMI, right? So this is pretty much it about the whole setup, the AWS setup, which we can see the overall something like this here. What we have done on top of this is that we have taken the source code from GitHub of the implemented storage manager. On top of that, we have added a thin layer of HTTP server, which is going to receive the REST requests from the internet. And depending on the method it receives, like get, post, put, delete, etc., it is gonna call the REST APIs and do the correct operation on the storage manner and give the results back. So what we have done is that we have taken this whole code base and put into these three nodes, and there we're going to compile and run it. And then from the outside, we are going to send requests to this ELB, and ELB is randomly going to forward the requests to these three nodes, and we'll see what kind of behavior is exhibited. So this is the setup. Now we will talk about the actual demonstration. So the software that we have deployed on these three machines, on the three nodes, are pretty much going to take care of this REST APIs. This three node setup is going to act as a master slave architecture, where one of those nodes is considered to be a master and the other two nodes will be considered as the slaves. As per the master slave replication, if a read requests come to the ELB, it is going to forward to any of these three nodes, irrespective of the fact that whether it's a master or a slave. The read request should be successfully executed, and the user should be able to read the data. On the other hand, for write request, there is a slight variation of behavior between master and slave. If the master receives the write requests, it will write it in its database first, and then it will replicate it to the slaves. So it will send a request to the slave through port 8080, and the slave, on receiving this request, will write this data to its database. On the other hand, if the write request first comes to the slave will first forward it to the master. Master will write it. Only after that write completion, it will send it back to the slave, and then slave will write it. So this is the master-slave architecture, and we are gonna demonstrate it right now. We have written down some test cases. We are gonna execute those test cases and see the outputs. Before we start, we just show that what kind of data we are gonna use to demonstrate this whole project. For GET request, as per the REST API, we'll just provide a key and we should get the value back. For POST, we're going to provide key and value, and this is going to create a record in the database. For PUT, again, we're going to use a key which must be already existing in the database and a new value. For a delete, we're going to use a key. With the help of this key, we should be able to find the particular record and delete it. Right. So we are going to log into the 3 nodes and start the server in all these 3 nodes. And from the Mac, where I'm currently recording this video, we'll use curl to put HTTP request to the ELB and see how these 3 nodes are behaving. So in order to log into these instances, we have to first get into Jumpbox, because these instances are not accessible from the public internet. So we will first log in into the Jumpbox, and from the Jumpbox we will log in into these 3 nodes. So we have 3 terminals logged in into the Jumpbox. From each terminal we will log into one node. So first let's log into host 1. Then we log into host 2. Then we log into host 3. Okay. So in all these 3 nodes, I have FTP'd the code. We are going to use the makefile inside this project to compile this project and run the server. So to compile, we first do make compile, and to run the server we do sudo make run server. So as you can see that the server is started, but I'm going to stop it for a time being just to show that I have designed a config file which actually tells that what is the role of this server, whether it's a master or slave, what is its own IP and the neighbor's IP, and what kind of partition mode it is going to use in case the network is partitioned. So this is all done in this config properties file. So as you can see, the partition mode is AP, its role is master, and this is pretty much the topology. Master IP is 172.30.026, slave 1 IP, which is this one, is 172.31.185, and slave 2, which is this one, is 172.30.124. And its own IP is nothing but the master IP in this whole topology, and that is 172.30.026. In a similar fashion, we have this config file in all the three nodes, and here you could see its own role is slave, and its own IP is 185. This guy is also a slave, and this guy is 172.32.124. So now we are going to start this three server. And as you can see, I have just printed the configurations that it is using to start, and it also says that yes, our HTTP server is started at port 80. Now I'm going to open one more terminal from my Mac laptop, and this will be used as a REST client. I'm going to send a HTTP request using curl of type get, and the body should be nothing but a key, that is color, and the destination is the DNS of the ELB. Just have a look at this DNS. This is nothing but this DNS. Okay, but right now this instances should be up in the ELB. Otherwise, if you forward this request to ELB, no, nothing is going to happen. There is nobody behind the ELB to handle this request. So we are going to wait for a while till the time these three instances come up. take some time for these three instances to come up. We have to wait for a while. Okay, so now we see that all the three instances are in service, so we can start testing through the ELB. So we're going to send a GET request to the ELB with the key as color. These three databases or three replicas to say are freshly started, so they do not have any data right now. So my GET request should fail. So this GET request failed with an error because, as expected, there is no data. And the request went to the master. You can see the method is get, the body is color, source IP is 67.164.87.287, which is nothing but the proxy IP, and there is no GUID corresponding to this key, or there is no record corresponding to this key, so this GET request couldn't be handled, so it has thrown an error, right? So let's create a request and then see if what the GET request gives. So we're going to create a record using a post request, and here is the key color and here is the value. So we are passing a key and a value in the post request to the ELB. Now this request may land to any of these three instances depending on the logic that ELB is following. Let's see what happens. So it went to the master. Master wrote the data. Then it tried to replicate it to the slaves. But somehow it found that the slave is not reachable, it's partitioned. So it did not forward the data to the slave. Let's see how it is partitioned. So in the outbound security rule, 8080 was not configured. So these nodes are able to receive the heartbeat messages in 8080, but it is not able to respond back. Hence, the communication between these three nodes were not possible. So master understood that the other two slaves are down, hence it did not forward the request. So let's add it back. Let's do a get on this data again. The get unfortunately went to the slave, but in the slave, this data was not written. Hence, there is no data. That's an error. Let's try that get again. Now that get went to the master, and data was written in the master already. Hence, we got a data back that color is black, and the node IP who responded with the data is 172.30.026, which is nothing but the master. And the data version is number 1. So let's delete this data. While deleting, we're going to just give the key, and it should be able to find out the record corresponding to this key and delete the record. It went to the master, and master found out the GeoID corresponding to this record, and it is deleted. We'll just do a query. It went to the second slave, where already this data was not there, so there is an error. But right now we just want to make sure that in the master we have written the record, and we should be able to delete it. We executed delete, but has it been already deleted or not? Let's just confirm. So we again execute get. It went to the another slave. Yes, it was already not there, so get said error. Now the request went to the master, and the result is error. Yes, so we have written a record before, and now the record is not there, so the delete operation was successful. Now let's take the test cases and understand the replication model. Using the same information, I'm going to do a post. Since now these three nodes are able to talk to each other, there is no partition. We will see that if one request comes to the master, what happens? If it comes to the slave, what happens? So we're going to post a request, which is nothing but a write request. It went to the master. Post request received. Master wrote it in its database. Then it checked whether slave 1 is alive. Yes, it is alive. Then it forwarded the post to the slave 1. In a similar fashion, it forwarded the post to slave 2. Slave 1 received the same post. Slave received post from master, and it also created a new record. In a similar fashion, slave 2 also receives this request from the master, and it has written this request. So basically, when the post request came to the master, the data is replicated to the slaves. How to confirm this? Let's use a get request. So no matter where this get request lands, we should be able to see the data that color is black. So we say, okay, so what's the color? Get. Now this get has come to this slave, and we are able to see color is black. And who has responded? 170 to 32 124, that is nothing but the slave, and the version is 1. Let's try the request again. Where did it come from? 185. So the request has been served by 185, and the color is still black. Again, it came from slave 2. The color is still black. This time, the request has been handled by the master, and the color is black. So one post request which went to the master has been replicated to the other two slaves, and all these three nodes are consistent. Next thing what we will do is that we will update this data and see if it is replicated all around or not. So the same color we are going to change from black to white, and we'll see how it is handled. So the request came to the master. Master says, okay, I have updated the record and the new record is color is white. And yes, the slaves are alive and I have forwarded this put request to them. Slave says, yes, I have received a put from the master and I have updated the record. Now we do a get on this ELB. We should be able to see the color is white, irrespective of the fact that from wherever this response is coming from. So the responses come from slave 1 and the color has changed to white and the version is 2. Now the answer came from slave 2 and yes, its consistent color is white. Now the answer came from 3, I mean the master, and yes, the color is white. So even the update request is being replicated all around the 3 nodes. Let's try another update request and see if it is handled by the master again or the slave. Okay, it is again going to the master at the beginning and then master is cascading it to the slaves. So right now if you could see that the version should increase and become 3. Okay. So this is all about the write requests. So from this we can see that read requests are being handled by all the 3 nodes. If the write request is coming to the master, then it is being written there and then forwarded to the slaves. Let's delete this record. Delete takes one key, that's all, as per the REST API. So delete came to the master and the record got deleted. Then the same request is forwarded to the slaves. Slave received delete from master, slave received from delete from master. So if we try get, then we should not be able to see the record in any of these 3 nodes. So the get request first came to the master and it said error. There is no such data. Now the get request went to the slave 2, error, no such data. Now the get request goes to the master back, no such data. Yeah, the get request came to slave 1 as well and it says no such data. So the deletion operation is also consistently updated to all 3 nodes. One additional thing that we need to see is if a write request comes to the slave, what happens to that? Now since ELB is not forwarding a write request to the slave, we might need to get into the jump box and try it. However, let's try it once more. Let's take one post request and see if we are lucky enough that the request goes first to the slave or not. No, not really. It still went to the master first. So in order to verify if the request first comes to the slave, what happens? We will need to log into the jump box and specifically target the request to one of the servers, slave servers. So we are into the jump box right now. From there, we are gonna update this record to one of the slaves and check the behavior. So in order to directly put this request to one of the slaves, we need to send it to the IP specifically. Its IP is 172.32.124. We will use that. So we're gonna send this put request directly to this slave node. So we tried the request in both the slaves, and in both the cases what we can see is that first the request comes to the slave. Slave received put from external network. Then it forwards the put to the master. Master then writes it in its database. Then it is going to replicate it to the other two slaves. So this slave gets the data back, and this slave also gets the same data. So this is the third principle of this is the second principle of the write request, that if the write requests come to the slave, then it should be forwarded to the master first, and then master should write it, and then master should disseminate it to the slaves. Now let's verify if this write has been actually replicated to all these three nodes or not. For that, we need not be in jump box. We probably can come out, and we can just use the get request on color and see. So it's yes, the color is yellow right now. It is responded by the master, version is 4. The color is yellow again, responded by the second slave. Color is yet yellow and responded by slave 1. So the consistency is maintained. So this is the whole master slave architecture that we have implemented using the SM implementation version 1 code and some HTTP server code and some hash mapping. Right now, the whole system is in a healthy mode where master, slave, all are able to talk to each other over port 8080 in the private network. And the configuration of these three nodes are in AP in case a partition happens. So we are going to create a partition right now and see that if the AP properties are actually applicable or not. So in order to create a partition, we are going to tweak the security rule which all these three nodes are using. We are going to turn off this 8080 port rule, which is allowing these three nodes talk to each other. Just make it like 0, right? I hope this makes these three nodes isolated from each other. For this testing, we will get into the jump box. Sorry. Right. And from there, we will test that what's happening exactly. Okay, so before partition, we have written a record, color is yellow. So right now, all the three nodes should be having the same record. So if we conduct a get, even though the three nodes are not able to talk to each other, all the three nodes should be able to fetch me that record. So let's do a get. On the master. I'm sorry, we have given the wrong IP. Yeah. So we could see it is showing the correct data, that is color is yellow, and the version is still 4, and it's responded by the master. Mind it, the network is in AP mode right now and it's partition mode. Now let's try to get the data from slave 2. What is slave 2 IP address? Yep. Color is yellow, responded by slave 1, version is 4. We will try the same on slave 2. Color is yellow, version 4, responded by slave 2. So all these three nodes are in sync, or I'm sorry, they are consistent right now. Now let's change the data. Let's do some write in the master and see what is the behavior of the other nodes. So we're going to change the color to white in the master. Okay. So the put request is received by the master. The master then tried to replicate it to the slave, but first slave is partitioned. It's not reachable. So put is not forwarded to it. Second slave is also partitioned. So put is not forwarded to it. So the first rule of write request is if it comes to a master, then it is not going to forward because there is no network between the master and slave. So the write should be executed only on the master. But the get could be executed on any of the nodes. So right now, if we execute a get on master, we will see the color is white because we just updated it. But the other two nodes, the color was yellow. We couldn't update it. So if we try to do a get on other two nodes, we should see color is yellow and an older version of data basically. So let's try the get from the three nodes one by one. So if we try it from master, where we just updated the record, it's version 4, color is white. I'm sorry, the version 5, and the color is white. If we try it from slave 1, oh, it's version 4, the old one, color is yellow. So yes, we did some write on the master, but it was not replicated to the slaves. Let's try the slave 3. It's version 4, the stale data. So this is AP property all about. In a partition mode, in master slave architecture, if get requests come to this master, it will be allowed. If a get request come to the slave, it will be allowed. If a write requests like post, put, or delete comes to the master, then it won't be forwarded to the slave. And if it comes to the slave, the write requests, then it won't be allowed. It won't be allowed at all. Let's verify that. Let's try to make color is green in the slave. It should not be allowed. So 185 is this slave. So it said we received a put from the external network, not from the master. So we have to forward this put to master first. But yes, master is not reachable, so put cannot be forwarded. And yes, AP mode is enabled. So sorry, we cannot handle put anymore. So a write request was rejected by the slave node. But let's verify. Has it actually been rejected? Let's check the color again from all the three nodes. So we'll check it from the slave one where we just have sent a put. Sorry that the IP was wrong. Ah, it's the old stale data. Color is yellow, version is 4. What about from the master? Master is having the fresh data, that's color is white. What about slave 2? Slave 2 is also having stale data. Okay. So we've seen that if get request comes, all the three nodes allow it. If put request comes, only the master allow, the slaves do not. If the post request comes, only the master allow, the slave do not. Now comes the delete request. Let's try to delete it from the slave. And as per the rule, it should not be allowed. Slave received delete from external network. It is trying to forward the delete to master first. It is checking if it's alive. No, it's not alive. So yes, since AP mode is enabled, I cannot take this delete. Is it the same thing with for slave 2? Yes. So how to verify if the delete has already taken place or not? Let's do a get on the slaves. Yeah, it's still having the data. Yeah, they are still having data. So the delete request has not been entertained. What if we forward this delete to the master? It is deleted in the master, and master is trying to forward this delete to the slaves. However, it has detected the partition and it could not forward it. Right. So what happened then? Has it been deleted from the slaves? No. Has it been deleted from the master? Yes. Let's verify. Yeah. So data is deleted from the master. How about the slave? It is second slave. Yeah. The stale data still there. How about the first slave? Yep. It also has the stale data. How about creating a new record in the master? Does it get replicated to the slave? I think we know that it won't. Let's just confirm once. So we create the record, shape is round. Now we check if the data is in master. It is, shape is round version 1. The data came from the master. Let's check if it has been replicated to the slave or not. No. What about the other slave? Nope. Okay. So can we create a record directly to the slave, like a post to the slave directly? IP was wrong, sorry. Nope, it did not allow. So this is pretty much it. Just to summarize, this is what we have seen, that in network partition mode, if we are trying to follow AP properties, then a read request will be allowed from a master as well as a slave. But a write request will only be allowed by a master, not a slave. Moreover, after executing the write request in master, that will not be or cannot be forwarded to the slave. Hence, a subsequent get from a slave will be giving a stale data, which is okay. So this is pretty much the demonstration we have. And this is how we implemented a master slave replication model in network partition mode and without network partition. Thank you.